Hey guys, welcome back to my channel. So picking back up from where we were yesterday. Yesterday we did the scatter plots. So you should still have this. You shouldn't have thrown it out, crumbled it up, or anything after you finished it. Because we are actually going to add something to it real quick. So we had our table, and then we had our table. We had our graph, but what we didn't do is we didn't really add a definition of what a scatter plot is or what a scatter plot shows. So down here near the bottom, just where you have some extra space, because you should, or you can do it off to the other side if you ran out of space, or honestly, just anywhere you can find on the paper. And you're going to write scatter plot. A type of graph that shows a relationship between two things. And so we often group these relationships into three categories. We often group them into three categories. They can be positive, negative, or pretty much none. And we call these correlations. So I kept using that word yesterday, positive correlation, positive correlation. Look at the positive relationship, right? Because we can see that the graph is going upwards. So we see that that's a positive correlation, a positive relationship. The older you get, the taller you grow. I mean, you know that. We could say the older you get, the more you weigh, right? And we still have a positive relationship because that number should be going up. So this is the definition of a scatter plot, a type of graph that shows a relationship between two things, and it can fall into three categories: positive, negative, or none. Now, a none literally just means what it sounds like. There is no correlation. They're not related. They have nothing to do with each other. I can say your eye color and how tall you are, and those two things don't go together, right? Your eye color doesn't control how tall you are. So there are things in the world, obviously, that have no correlation to each other. They have no relationship to each other. And so when we're talking about correlations, we need to be looking at between these three things. We can also have negative correlations. I talked about that yesterday too. That's when the graph is going down. That's when the graph is going down. So if we reversed this and kind of thought like, I'm trying to think of a reason why the graph would go downwards instead of upwards. And you can take the data here and kind of reverse it and make it go down. Like the younger you get, the less you weigh sort of thing, right? But for the most part, yeah, we're going to have positive correlations going up, negative correlations going down, and no correlations, meaning the data is just all over the place there. It's not correlated. There's no relationship there. All right. That's going to wrap it up through scatter plots. Do not lose this. Do not throw it away. Don't crumple it up and light it on fire. Like, we need these, right? So I'm going to have you flip to the next build page. This is what's really nice about using a journal. If you've got a spare journal lying around, is because we're going to go page to page, right? So if you can save your journal, Then you don't have to have a bunch of like random loose leaf scraps of paper lying around. I have a meme for you guys. I had to print it. That's pretty old school. So there's your daily meme for today. We're all feeling it. We're all feeling it. All right. So what we're going to do over on this page is that we're going to do more types of data, but over here we're going to show different ways to represent the same data. So title it Representing Data. Title this page, sorry, it keeps like refocusing, Representing Data. Because we're going to take some data and we're going to represent it two different ways to show you that that sometimes when you get data, there's multiple ways that you can represent it, like multiple. You could use like a line graph, a dot plot, scatter plot. But usually there's one that's like better than the others, if that makes sense. Like there's one graph that's like, okay, that fits a little bit better than the other graphs did. Like, can you imagine using a pie chart for like any and everything, right? And then we're going to write this problem. A baker had 10 sacks of flour containing, I don't know why I put a period there, containing the following amounts. A baker had 10 sacks of flour containing the following amounts. Zoom in a little more, make it brighter. Probably not. So these amounts are going to be, let's see, 4 1/2 kilograms, 3 1/4 kilograms, 2 1/2 kilograms, another 2 1/2 kilograms. Ooh, it's already making me think that there's a certain type of graph that'll fit this better than other graphs, right? I'm seeing some repeating data. That's, I mean, some graphs are better lent to repeating data than other graphs, right? 4 kilograms, then we have 3 1/4 kilograms, 4 1/4 kilograms, 5 kilograms, 2 1/2 kilograms again. All right. 2 1/2 kilograms, and then finally 3 1/4 kilograms. So just 10 numbers, right? I mean, it told us at the very beginning of the problem that it would be a total of 10 numbers because he has 10 sacks of flour, obviously. So not a ridiculous amount of data here. I mean, when you only have 10 numbers, it's really not that much data. The only thing new about this is that we haven't really dealt with data that has fractions as part of it. Like, of course, in the real world, you're going to have data that has fractions. It's just a little more unfamiliar territory, right? That doesn't mean it's not possible. It just means it's a little new. So keep taking down that data if you're still writing. And we're going to show this in 2 different ways. So because I had repeating data, I'm already thinking a dot plot. So why do you think I'm thinking a dot plot? Yeah, because, I mean, this is like Blue's Clues where I'm like, or Dora the Explorer. I'm like, answer the question. And then I like just do an awkward pause waiting for you to answer. So the reason I'm thinking dot plot is dot plots are made for repeating data, right? Like you do the numbers underneath and then you do the dots on top, and the dot shows how many times that same number shows up. So dot plots are made for repeating data. It's literally like their best job. And then the other one we might use is, see how like we're starting with a lot of the same whole numbers, 2, 2, 2, 4, 4, 4, 3, 3, 3. I'm thinking of stem and leaf. I'm thinking of stem and leaf because I'm starting with the same whole numbers and the fraction is the only thing that's changing. And I can make a stem and leaf like that as long as I make the key match. So go ahead and divide your paper up into probably actually halfway like this. So give yourself, and we're going to do representation number 1 and representation number 2. I'm going to make, this is going to be a dot plot. We're going to do a dot plot first, just because, like I said, I did see some repeating data. So a dot plot starts with a number line. And before we forget, let's do our key and let's do our labels. So going back to the story, what were all these numbers? What were all of the numbers in our data? Yeah, they were kilograms of flour, right? Sacks of flour. So we can put weight of flour sacks. Weight of flour sacks. And that's the kind of title of our dot plot. The title of a dot plot goes underneath. We're going to do a key. So every one dot, so we're like key, every one dot equals one bag. Sometimes we put our keys in little boxes too so that we kind of easily see them. I might separate my data too from this graph that I'm making. And let's see where we need to start. So we need a range here. We need to start definitely below 2.5, so maybe around 2, and we need to go all the way up until 5. And so let's go ahead and just do our whole numbers first. 2, 3, 4, 5, that'll work. 2, 3, 4, 5. So we're doing our whole numbers first because that's easiest. We know how to do whole numbers on a number line, right? Like we've been doing that forever. We do our whole numbers first, and then we're going to go back in and we're going to do the fraction amounts. And I promise you, if you do it like this, it's much easier. These number lines, and it stops becoming so scary. So we know that we're going to need halves, right? And making halves is easy. Making halves is just half. It's halfway between the whole numbers. So we're going to make little tick marks halfway. So we know those are 2.5, and that's 3.5, and that's 4.5, right? We don't need to label them. We get always stuck in this mindset of like every single tick mark, every single little line needs to be labeled. Don't do that to yourself. One, it looks terrible, right? Because you have a bunch of numbers all shoved in here together. And two, it's just a lot of work. Why do it? I mean, we know this line needs 4.5. You don't need to write it to know that. So now I have my half. So what I'm missing is my fourths. Well, if you know anything about fourths, you know that a fourth is half of a half. That sounds confusing, but I can divide this whole 2 to 3 into 4 pieces pretty easily. I just need to add 2 more lines. I need to cut the halves in half. So maybe now I'll make the middle lines a little bit bigger, my other halves. And I'm going to cut them in half again. So now we can see that, I mean, the dot plot's ready to go. It's ready to go. You cut it into fours. You got all the numbers you need from up here are here. So let's start plotting them. I'm going to start with my lowest number. So I see 2.5, 2.5, 2.5. I see 3 2.5s. Okay. So no 2s, no 2 4s, but I've got 3 2.5s. Okay. So 3 dots go above 2.5. Now that's it for the 2s. So now I'm to 3s. I don't see any 3 holes. I do see 3 1/4, 3 1/4, 3 1/4. Okay. So if this is 3 and this darker line is 3 1/2, then halfway between those is 3 1/4. So I'm going to do 3 dots there. Okay. And then, do I see any more numbers in the 3s range? No, I do not. So moving on, there is a single 4 hole here. So don't skip over him. There's 1 4 whole kilograms here. So there's 1 dot above the 4. And then I see a 4 1/4. So there's 1 dot, just 1, above 4 1/4. And then I see a 4 1/2 right here. So there's 1 dot above 4 1/2. And I think the last number we have, go ahead and say it for me, kids. Yay! Yeah, it's fine. So, alright. And to make sure we did everything correctly, we know that there was how many numbers up here? How many sacks of flour? 10. So we should have 10 dots here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Your dot plot is done. So the dot plot made sense because, I mean, we did have this repeating data here over and over again. And then right here it wasn't as repeated, but it still wasn't an overly complicated way to represent this data, right? We can see that the majority of his data are flour bags are in this range, some of them are over here. Okay. And the last representation we're going to make together, is going to be a, oh my gosh, I blanked out. So we're going to make a stem and leaf. And I'm thinking stem and leaf only because, like I said earlier, I see a lot of the same whole numbers. And we can use stem and leaf with whole numbers and fractions and even whole numbers and decimals. So if it's been a while since you made a stem and leaf, no worries. I think it's been a while for everybody. So on one hand you have your stem, and on the other hand you have your leaf. So we have stem and leaf, and I just barely didn't give myself enough room for a title, but I need to put one in there. So weight of flour sacks, and I need to add kilograms, and I forgot to add that last time. I made a fatal error, y'all. I tell you so much that you got to include the units, and then I forgot to include the units. Boo. So make sure you include your units. We're not talking about ounces, we're not talking about pounds, we're not talking about tons, right? We're talking about kilograms. It lets us know what the data looks like. So the first thing with a stem and leaf is that we got to create a key. And our key is going to show us what the stem is worth and what the leaf is worth. So for example, if we had like 1 and 3/4, then on the stem and leaf that would look like 1 and 3/4. So our whole number is the stem, our leaf is the fraction. Okay? Our whole number is the stem, and our leaf is the fraction. Our whole number is the stem, and our leaf is the fraction. Okay. Now that we have that done, let's get going. So we can, honestly, I can use the teta for my dot plot and go up here. It's just the same data again. We know our whole numbers. We didn't have any whole numbers of 0, none of 1. It starts at 2. There was a 3, a 4, and a 5. Okay? So let's start. The 2, we had 3 2.5s, right? I can see it right here. 3 2. So I'm just going to write a half, and a half. And you put commas in between them to show that they're different amounts, they're different numbers, right? And for the 3, we're going to do, and feel free, by the way, feel free to pause this video, do all of it yourself, and then just jump ahead and check your work. No one said you have to work at my pace. I'm doing this for those of you that want to work at my pace, but if you'd rather skip ahead and then check back just to make sure you did it right, that's totally fine too. Because in the end, you're still going to make sure you did it correctly. You're still going to check your work. The next 3 that we had were all together again, and they were 3 1/4, so it's going to look kind of similar. 3 1/4, 3 1/4, 3 1/4. That next number we had, take a look at that. That might be a little confusing to some of us. We see 4, and we see just the 4 wholes, right? So there is no fraction. There is no fraction. So that's just going to be a 0. We can't put nothing. We can't just put nothing because then the number doesn't count. Then there's technically not a 4 if we don't put anything there. We need to put the 0 to show it's 4 wholes and 0 fraction. Because that's still 4 wholes in the end, right? So, 4 wholes, 0 fraction. There was 4 wholes and a 1/4. And then 4 wholes and a half. And then our last number was 5 wholes. So because of what we just did with the 4 wholes, you should already be thinking, I know what to do for that 5 wholes, right? We can't just leave it blank because then it means it's nothing. It doesn't count. That means no data. If the leaf is blank, that means there's no data for that 5. But there is data. There's 5 wholes. 5 wholes, 0 fraction. Okay? All right. That wraps it up for me. I miss you guys. I hope you're doing well. Finish these notes, and then tomorrow you'll get some practice on your own. So save this stuff. Save this stuff. Plus, we're just going to add it back to your journal when we come back to school. All right. See y'all later.